two fires, 30 kilometers apart. Two fire towers, sorry, 30 kilometers. So they didn't label that for us. Where A is due west of B, they did put that in for us. A fire spotted from the two towers. Bearings from A and B are 76 degrees and 304 degrees respectively. So remember, when you're doing bearings and they don't give you direction, that's from north line measured clockwise, 76-degree bearing. North line measured clockwise, 304-degree bearing. But they drew that in for us, so that shouldn't be an issue. Find the distance of the fire between the two towers. So we want to figure out the distance from the fire to tower A and the distance from the fire to tower B. So I'll just label those X and Y. All right, so I guess there is a right triangle in there. So if you ever did enough work to figure out what D was, oh, I didn't read the question very carefully. Actually, that's what they want us to find. Find the distance of from the line between the fire towers. Yeah, so D is what they're actually searching for. What's the distance between the fire and the line between the fire towers? All right, so I know I can do SOHCAHTOA stuff as long as I'm careful about right triangles. I've got law signs and law of cosines, but you know, it's not immediate to me what I should do. So I'm going to just kind of throw in some information that I can find easily and then really kind of analyze. So knowing that this is 304 degrees should tell you this angle in here, because this is 90, this is 90, this is 90. So this is 270 of that 304. So that means this piece has to be 34. Also, these are due west of each other, so we can assume this is a 90, so this is 14. Okay, so we need more information. So let's find this length, and then I'll show you why. I guess you could find this length if you wanted to. If you're unsure what to find, you should just find something and then add it to your picture to see if it helps. But I know I can find this one reasonably easy because this should be law of sines. I've got its opposite angle. I know another length, and I can find its opposite angle. If this is 34 and this is 14, the last angle of the triangle would have to be 132, so that they all add up to 1/8. So again, it's not that you have to find what I'm saying is X. I just think that that's going to be a good approach. .574. Okay, so every time I get another piece of information, I'm much more likely to be ready to give the answer that they want. And the answer that they want is this length of D. Okay, well now, again, you can keep going law of sines and law of cosines. I'm sure there's 20 different ways to finish this question. But if I just focus on this triangle, which is now a right triangle, well, right triangles is fair game for SOHCAHTOA. I can say from this angle, I want to know opposite, and I've got hypotenuse, which is always sine. So it looks like that distance D is going to be what I have for X times the sine of 14 degrees. In fact, this might be the exact question from last semester, I'm not sure. That number seems familiar with that. And so just to be clear, I'm not saying this is the only way to do it. It's not that you need to memorize these steps. But what I did was I looked at what I had. I figured out, okay, this angle is easy to find. This angle is easy to find. So that angle is easy to find. Based on the information I had, I saw I could do law of sines to get more information, like a side length. And then at that point, I just said, okay, well, I've got enough information now. I could finish it with the SOHCAHTOA equation. But I didn't know it was going to play out that way from the beginning. Sometimes you just have to find something, add it to your picture, see if it's enough. If not, then keep going.